Hello students. So this question here says the figure shows two blocks A and B each having a mass of 320 grams connected by a light string passing over a smooth light pulley. The horizontal surface on which the block A can slide is smooth. The block A is attached to a spring of spring constant 40 whose other end is fixed to a support 40 centimeters above the horizontal surface. Initially, the spring is vertical and unstretched. When the system is released to move, find the velocity of block A at the instant it breaks off the surface below it. The value of G has to be taken to be 10. So, this is the figure in hand. The two blocks connected through a string shown in black is the original state of the system. See that block A is connected to a spring which is vertical initially. And because of the weight of block B, the system will start moving towards right, block A will move towards right, block B will move down, and after a certain time as they reach in the second state that I have drawn here in grey, the block A lifts off from the ground, just lifts off, and we are supposed to find out the velocity of the two blocks at this particular instant. So how are we going to approach this problem? We shall use first the force equation to get the condition for the normal reaction of the block A from the ground becoming 0, because that will be the condition for the block A to break off from the surface, right. Once we get the condition for that particular moment, we will use that condition into the law of conservation of energy. Why do we use law of conservation of energy? Because we see here that there are no dissipative forces, there is no friction anywhere. The only forces acting on the system are spring force, then there will be gravity acting on B which is making it move, and the tension force between A and B. And the spring force and gravitation force, both we know are conservative forces, they do not dissipate the energy of the system. So, here we can easily use the law of conservation of energy considering both the systems, both the bodies, both the blocks as a single system. So, we will start. So, first of all we will find out the condition for the normal reaction between block A and the ground to become 0. We say that at the moment of break off, the normal reaction N will become 0 between the block A and the ground, so that along the vertical we can balance forces like this. See that Kx here is the force that the spring exerts on A along the spring as it gets stretched by an amount x. So, here we are assuming that as the block moves from its initial to final position, the spring in the process gets stretched by an amount x, and Kx then becomes the spring force. The component of Kx along the vertical then should balance mg, the vertically downward force acting on block A, because along the vertical block A has no motion right now. So, we can balance the forces along the vertical. Once we balance them, we get a relationship between the angle theta that the spring makes with the vertical, with the weight of the block and the spring force, which we can write in an equation like this. See, cos theta can be written as, using this right angle triangle that we are obtaining here, y by the y plus x here. C is the length of the hypotenuse, because y is the original length of the spring and x is the extension that it has suffered as the block A moved from its initial to final position. So, this length here of the final length of the spring, which will also be the hypotenuse for this right angle triangle, will be y plus x. So, cos theta can be written like this, and using this equation we can find out the value of x, because if you see here we know everything else except for x. Once the value of x is known, we can substitute this value here to get the value of s. What is s? S is the displacement of block A in the process of moving from the initial to the final position. So, S we can calculate once we know y as well as y plus x. Y is already given to us in the question, x we can calculate from the previous equation. So, S can be obtained once again by using this trigonometric identity for the right angle triangle that we have here. We are calling this equation number 2. So, using these two equations, we can find out the value of x as well as s, and now we can use the final equation, which is the law of conservation of energy, taking both the blocks together as a system, and we are going to use this energy conservation between the initial position of the two blocks and their final position. where we are assuming that finally, let us say the two blocks are moving with the same speed v. Understand that both the blocks at any point in time will have the same speed because they are connected through one single string. So, the conservation of energy principle when we try to use, see that initially the system is at rest, both the blocks start from rest, so their kinetic energy will be 0. And if we assume that at the initial position where they are, the block B where its position is, if we assume that its gravitational potential energy is 0, then the gravitational potential energy of the whole system of both the blocks can be taken to be 0, right? And so, both the energies come out to be 0. So, the total initial energy of the system is 0. Finally, if you see, the spring has got stretched by an amount x. So, there is a spring potential energy with the system. The block A remains along the same horizontal level, but the block B has gone down by a distance s. So, it has lost potential energy, gravitational potential energy by an amount mgs. So, the new gravitational potential energy of block B will be minus mgs plus the kinetic energy of the two blocks, which will be 2 times half mv squared if both the blocks have a speed v. So, this is the conservation of energy equation and we call it equation 3, and now we can just substitute the value of s and x in these two terms to get the value of v solving this equation. I have done the detailed calculations here for you all. If you want, you can just pause the video and have a look at the calculations also to see the final answer. So, see that this is an interesting question which involves two concepts, the Newton's law of motion as well as the law of conservation of energy. So, a good practical question to approach. Thank you.